Assuming that I'm live, okay? So if anyone has joined, just give me a thumbs up or just like do something like just to let me know that I'm live. So let me check whether I'm live or not, okay? So if I'm live, I'll just start with the video. From my side, I think it's almost going to show, okay? Okay, it started. It's let me check whether I'm live or not. Okay, I can hear myself perfectly. And I'm perfect. So let's start with this video, with today's video, okay? So today there was this division 4 thing. So without any ado, so I'll just remove this, okay? This is standing, okay? I'll just remove this also. So let's start with problem A. Problem A states that you're given two numbers, A and B, and A is always lesser than equal to B for all the possible values of C, and C is like A is lesser than equal to C is lesser than equal to B. You have to find the minimum value of C minus A plus B minus C. So let's get into the code, okay? Okay, so this is what I was doing for the previous video. So let's get into the code directly. Let's get into the explanation, okay? So let's say we have a number A, we have a number B, and there's a number C. So basically on the number line, let me draw a number line using this. Okay. So basically on a number line, we can see that the values are going to be somewhere over here, right? Because it was given that the value of this is lesser than equal to, and this is lesser than equal to B. So we are very much sure about this fact that, just let me check if I'm lagging or not, okay? Just wait a minute. If anyone is watching this, just tell me if I'm lagging, okay? You are going to be somewhere over here, right? Because no, I'm not lagging. So, anyways, whoever is joined right now, hi. I can't say anything more than that. So just tell me how was your Codeforces contest? Okay, just tell me how was your Codeforces contest. So I haven't started it yet. So what I'm doing is like, I'll just pin it. Okay. Pin this instead. Okay, so let's get into the video. So like A and B, we know the value, and this is the value of C. Now it was given in the question that we have to minimize the value of C minus A and B plus B minus C, the addition of both of them. Okay. Now we see that C minus A is basically this part, and B minus C is basically this part. So no matter whatever the value of C, the value of this C minus A, the value of C minus A plus, it was given, plus B minus C, right? Plus B minus C. So basically what happens, C and C cancels out. It is basically B minus A. Okay? B minus A. This was very simple. So I'll just go with the code once. Okay. The code is very simple. So this is the number of test cases. This is A and B. And whatever the answer is B minus A. Okay? Clear? So if anyone is watching this video, just tell me if it's clear or not. Okay? So wait, just let me ping it up on Discord so that people can join. Thumbnail looks awkward. Anyways, I think I should change the thumbnail also. So meanwhile I'll be explaining B, I'll just also be changing the thumbnail. So if you look at B, the problem is Osu, not Mania. Okay. So you're playing your favorite rhythm game, Osu Mania, and the layout of your beat map contains n rows and 4 columns. Because nodes at the bottom oh yeah, anyways, today's Codeforces was unrated. Okay, today's Codeforces was unrated. So what happens is, because nodes at the bottom are closer, you will process the bottommost row first and topmost row last. So basically, you have to traverse from the bottom to the top. Okay, and each row will contain exactly one digit. Each row will contain exactly one digit, which will be a hash. Okay. So we have to find the position of hash basically for every row, but we have to do it from the bottom. So from the bottom, what we can do, we know that we have a so let me just draw it. I think I don't need to draw it much, because this was a very simple problem. So basically, let's say you have since you know that the size is always like 4, so a hash will be present in any of the 4 boxes. So if the hash is present at 0th position, so the output will be 1. If it is present at 1th position, it will be D से करो भाई, जल्दी जल्दी कर देते हैं, ठीक है, C तक जल्दी जल्दी कर देंगे, उसके बाद D से करेंगे. This is 3, right? So this is what basically it is. So basically, like, I'll just go through the code, since like there are people waiting for me to do D. So I'll just basically go through the code very fast. So what we do is, we basically just traverse through the whole thing and check out the position of the hash, and based on that we just print it. But remember one thing, when we are printing it, we do it in reverse order. Okay, this is clear. So let's go to C quickly, and then we'll go to D. Okay, said bro, we'll go to D से करेंगे भाई, टेंशन मत लो. So Freya the Fog is traveling on the D coordinate. So she is currently at 0 position, and she wants to go at XY position. And what she can do is, in every move, she will alternate between facing the positive X direction or the positive Y direction. So basically, in every move, what she does is, basically, if it is the first step, she makes X plus 1. So if it's the first move, she makes X plus 1, and if it's the second move, she can make Y plus 1. Not plus 1, it was K, right? It was K, I guess. So let me just check it once. Yeah, she can go from 0 to K. Okay, so this will be ranging from 0 to K. So basically, this is the maximum thing that he can do. So see that based on that, we can find like how many operations that he needs to perform, how many jumps he needs to perform, and how many jumps to go from 0 till Y. And based on that, we can find that in what number of at positions 1, 3, 5. So the pattern is basically the number of jumps into 2 minus 1. So if he's in the first position, if he needs to make one jump, it will be 1 into 2 minus 1, that is 1. And for this, it will be 2 into 2 minus 1, right? 2 into 2 minus 1. So it is basically jumps into 2 minus 1. But for this, it is going to be 2, 4, 6, so on. So it is basically j into 2 only. So whichever is going to be the maximum, you have to find out. Okay, so just I'll go through the code real fast. I think from this code there was a problem that the server was like not responding perfectly. So what we do is first we count the number of jumps, that is xx, that is x by k. You know, like if you can jump k times in one operation, so you need to jump, like to jump x length, he needs to do x by k jumps, and similarly for y also. And as I told you that what he does is, okay, so this is the mod thing, that is if he has to jump extra or not. So this part of the code is very naive. And then what we do is like the formula that I told you, j into 2 minus 1 and j into 2. So whichever is maximum, he just prints it. I hope this is clear, right? So guys, just respond, because I'm going to go for D right now, okay? Just respond if how many of you are here, because I don't know, I can't see, okay? Because I'm doing some work on my, like I'm just uploading the thumbnail. Okay, just let me upload the thumbnail and then I'll just look at the number of views, okay? So anyways, we are going to D, okay? The problem D, it's a problem by Satyam. This guy is great at problem setting. I have just discovered Satyam recently, but this guy is damn. Okay. So let's go with D. So what Satyam does is, Satyam is given n distinct points on the 2D coordinate. It is guaranteed that y is from 0 to 1, and for all the points xi, yi, the y is from 0 to 1, okay? So he wants to find how many how many different right angles can he form, okay? So whenever we are talking about different, it means that all the 3 points are, like any one of the 3 points are different, okay? So that is non-degenerate, what he basically means. So that's it, okay? So now let us see this example, okay? Now if we are talking about this, so you can notice one thing, that this thing, this thing, this point, if they are on a straight line, so they can make, from the remaining points, they can make a right angle triangle, okay? But there is an exceptional case for this point, for 2, 1. So whenever you see 2, 1, you see that this is going to make a right angle triangle with 1, 0 and 3, 0, because, so let's go with this. So first I'm going to discuss the 2, 1 thing, okay? So 2, 1. After that I will be discussing the basic thing. 2, 1. This is 90 degrees. This is going to be 1, 0, and this is 3, 0. Okay. Now this thing happens because, like, you know one thing, that if this is 90 degrees, so this is very much clear that if it is not directly straight, so if this was straight, it would have been a different thing, but it is not straight, because if it would have been straight, the 90 degrees will be over here, right? But the 90 degrees is at this position only. So when it's at this position, we know that these two angles, we are not sure about. We are not sure about what these two angles are going to have, okay? But if we look very carefully into this, since all the values are integer, okay, now we know that the distance between this and this, so let's just calculate the distance between this and this, okay? So if we calculate the distance between this and this, it becomes √2, and this also becomes √2, right? And this is 2. Okay, so which basically satisfies the Pythagoras theorem. Now from the Pythagoras theorem, we can see that the converse, for the converse thing, it is always true that it is a right angle triangle. Now what if this √2 was √3, and this was something else? So if this was √3, so this had to be √1. Now see one thing, that it can't be √1, okay, because if it is √1, that means it is at a distance of 1. So it will be basically over here, right? So if it is basically over here and we want to make this 90 degrees, so this will be over here, right? Any point over here, which will be very much contradictory. So that is only for this 2 thing, okay, this 2. Now for any value we can prove this one thing, that since all the values are just one below it, if it can be proven that this and this, they will be same, because this will be a right angled isosceles triangle. Okay, this is a right angled isosceles triangle. I don't know whether I'm writing the spelling right or not, but I'm just guessing that this is the spelling. Okay, so isosceles triangle. So this isosceles triangle, what it basically does is, like, let me just check it. So it's just showing me that no one is over here. Okay, no one is watching this. Why is it so less, man? I don't know. Anyways, so it has to be the isosceles triangle. Okay. Now since it is the isosceles triangle, and we know that it has to be 45 degrees, so we can just go on by expanding this more, right? But if we expand it more, it will be an anomaly for us. Okay, it will be an anomaly for us. So let's say, so you may say that why is it isosceles triangle, and you may ask me to prove it. Okay, now we know that all the sides are basically in integers. I mean, all the points are basically in integers, right? Now since all the points are basically in integers, so let's say if there is a point, like if we want to make this, we want to shift this angle, so if we have to shift it just a little bit over here, so the point this 3, 0, it becomes 2, 0, and if it's 2, 0, then this will be over here and this will be over here, right? So it won't be satisfying. And if we want to make this right angle shift over here, the same thing happens. The right angle shifts like this. Now you may ask me that what if, like, we shift the right angle by a slight angle, okay, by this angle. So we know one thing, that if, let's say this is a right angle, okay, this is a right angle perfectly, but this position, it will be a fractional position, and the inputs are always integers. So this is the trick behind it. Okay, so basically what you have to do is, whenever you're finding a point having this 1, it can make a right angle triangle with points at 0, where this is x minus 1 and this is x plus 1. Okay, so this is the only condition when this satisfies, because if we do that, the calculation, so if it is x plus 1 and this is x minus 1 and this is 1, so it will be root 2 always, and if it is this, then also it will be root 2, and root 2 and root 2, the difference is over here, it will also be 2. So basically this is the only possible right angle triangle which is unique. Now what about the remaining right angle triangles? Okay, so this is just one condition that you have to consider. Now what about the remaining right angle triangles? Okay, so let's say we have a point over here, x, 1, and we have a point over here, x, 0. Now apart from the first condition that I was discussing, so we can draw a line over here. Now anything, if we are connecting any point to it, any point, it doesn't matter, any point, it will be forming a right angle triangle. So from the total number of points, okay, from the total number of points, if we just take out these 2 points, okay, if we just take out these 2 points, so that is the total number of right angle triangles that these 2 points can make combined. Okay, so basically this happens when both the values, this and this are 1 and 0, and these 2 values are the same. Okay, so we got 2 cases. Okay, first case and the second case. So let me just explain the first case. The first case is the case that I just told you, that is x comma 0, x comma 1 and x comma 0. So in this case, what you can do is, you can say that there will be total number of points minus 2 points that can be made by these 2 points. Why? Because minus 2 is because we are just taking off these 2 points and that's it. Okay, so we can make it. And for this, any point at x comma 1, if it is having x minus 1 comma 0 and x plus 1 comma 0, then it is going to make 1 point. Okay, so then it's going to make 1 point. 1 point. This was points minus 2 and this is going to make 1 point, and the vice versa is also satisfying. That is x comma 0, x minus 1 comma 1 and x plus 1 comma 1. In that case also we will be getting 1 point. Clear? So let's get into the implementation of this problem real quick. So we know that D was like this. Okay, so D is like this. The problem D. So it was given in the problem that the value of xi, it is always lesser than or equal to n, and it is from 0 to n. Okay, so what we can do is we can use a frequency map, and for that frequency map, not the frequency map, we can just have, like, since all the points are also unique, so yeah, we can have a frequency map, like at y is equal to 0, how many x values we are getting, and for y is equal to 1 also how many x values we are getting. So I think it will be better if I explain you using this, showing you the code. Okay, so basically we have frequency 0 and frequency 1. So this is for y is equal to 0 and this is for y equal to 1. Okay, now we are taking the values of x and y. Now this was not needed, actually. This was not needed. So I'll just remove this thing. Let's make this n minus 2. Okay, I'll just remove this thing because I think this was like extra, which I later realized. Okay, so what we are doing, for every point we are taking x and y, and if y is equal to 1, because if y means that it is non-zero. Okay, so basically if y is equal to 1, what we are doing is we are storing that into frequency 1. Else, if y is equal to 0, we are storing that into frequency 0. Okay, so we are just modifying the frequency values for everything. So this was also not needed. Now this is we are just initializing the answer, and for every point, for every value of possible x, we are going to find if that value of x is present at either y is equal to 0 or y equal to 1 or not. So if it is present at both the positions, okay, if it is present at both the positions, frequency 1 and frequency 0, so that means that we can have the second condition. Okay, the second condition, that is this. The first condition. Okay, that this is present over here also, at 1 also and at 0 also. So we can make points minus 2 directly. Okay, so that is n minus 2. We're making it. And apart from that, if, like, this is just to check that there is no underflow or overflow. Okay, this is just to eliminate any underflow or overflow. Okay, so we have to check whether the frequency of 1, it is happening that frequency that at first position there is a I, and at 0th position I minus 1 and I plus 1 exists. That is this condition. This condition. Okay, and the second condition is that frequency of 0 at I is present and frequency of 1, I minus 1 and I plus 1 is present. That is this condition. Okay, so in both the conditions we are just adding 1 to it, and if it's not so, we are just adding n minus 2 to it. Okay, so these are the two conditions that we need to consider. This is case 1. just let me write it, case 1, and this is case 2. Okay, clear? And this is answer. So if we like run the answer, so you can see that it's got satisfied. Okay, it's taking a lot of time, I don't know why. Yeah, so you can see that it satisfies. Okay, so now we can go to the next question. I'll go quickly to the next question. Klee S draw. Okay, Klee S draw. Klee super duper large array. So basically what Klee does is like he has an array A of length n where it is like k plus 1 k till k plus n minus 1. So the length of the array is n, and he wants to choose an integer I such that the summation of all the elements from first position to ith position and the summation of from I plus 1 position to nth position, if we subtract it and make the absolute value, so it is minimized. So we have to find the minimum possible value of that absolute value. Okay, now if we go for normal like construct an array of big O n, okay, so it is going to take us a complexity of 10 to the power 9. Okay, so if we go for big O n, like make a array of size 10 to the power 9, so it will be big O of n, and it will be costing us a time of 10 to the power 9, and we know that 10 to the power 9 is always going to give us a TLE. Now obviously we know one thing, that anything, so if big O n is going to give us a TLE, so what is going to save us, right? So you have to think about what is going to save us. So in order to save us, we will be needing big O of log n. Okay, now what is like, how are we going to apply this log n thing? So whenever we are talking about log n, you know, like things that comes to our mind, binary search and stuff like that, right? We will be needing big O of. Okay, so if you're talking about binary search, okay, so let's say we can find that what should be the position of I, because we are going to binary search the position of I. So let's say the left value, so we know like whenever we are performing binary search, it is like L and R, right? And the condition is while L is lesser than or equal to R, right? So L can be at position 0 and R will be at position n minus 1, right? More like, let's not talk about this. So L can be K, because over here we are not going to consider the position. Okay, we are just basically going to consider the specific element. And R is, what was it given? It was given that R is K plus n minus 1, right? R is K plus n minus 1. Now since we have got this K thing, we have got the K plus n minus 1 thing, now we are going to do some binary search, okay, between this. Now let's say we have to find that what is the best position. Okay, so whenever we are going to consider what is the best position, it will be obviously better if we can find a point with the sum of the pre-sum. So let's say we have this array like this. Okay, this is the array that I'm talking about, and at this position there is a partition. So it will be obviously better if this sum and this sum, if both are same. So basically this sum is equal to the sum of this whole array by 2. Okay, so we have to make it as close as possible to that value. So if we get a value, like let's say we make a partition over here, okay, and this value of this sum is lesser than lesser than equal to 2, lesser than equal to the total sum by 2. In that case, you have to shift the value of L over here. But if it is like over here, we are just doing till here, so in that case we had to shift the value of this over here, right? So let me do one thing. Let me just change the color a little bit. Till here it was okay. So I'll just change the color to make you understand. Okay. So let's say we have taken into consideration this point. Okay. This point. So basically, what is the value of sum going to be? The value of sum is going to be lesser than equal to, for this position, it is going to be lesser than 2 into total sum, right? Okay. Okay, my handwriting sucks. Anyways, it is going to be lesser than 2 into total sum. So in that case, what we are going to do, we have to make the value of L come over here. Okay, this L comes over here. Just after that. But what if it was like this? We had a value over here. So in that case, we can say that this sum, this will be greater than this, right? This will be greater than this value, this value. So if it is greater than this value, it will be better that we shift the value of R to the left of this. Okay, by doing this for few number of times, we can find out what is the best approach for us. And for every specific element, we are going to do it. Now, how we are going to find the total sum? How we are going to find this sum? This is a very good challenge for us. Okay, so if we are just focusing on finding the sum of this whole array, we can just have the formula of n into n plus 1 by 2. Okay, n into n plus 1 by 2. This tells us the sum of all the first the first n natural numbers. Now we know that one thing, that this is basically the sum of first n natural numbers, and we are going to subtract the sum of k minus 1 natural numbers. So we are going to find the sum of k plus n minus 1 natural numbers and then subtract the sum of first k minus 1 natural numbers, so we get this total sum. Okay, and for every specific element we can use that formula. For every specific element, okay, we can use that formula. So let's get into the code. It will be better for you to understand. So we are taking a value n and k. We are just taking the input. Answer is initially 0 because we don't know what is going to be the answer. So we are just initializing it. It's not like we are just setting its value directly. Okay, we are just initializing it. Let me focus my camera. Okay. So what we do is, as I told you, I'm fixing the value of L and R over here. And SI is basically the sum of first k minus I terms. As I told you that we have to ignore that every time. Okay. So if you look at this thing, it is basically the sum of first k plus n minus 1 terms, but we are going to ignore the first k minus 1 terms, right? So basically this is ignoring terms. This term is ignored, sum ignored. Okay, SI means sum ignored. So let me write it. Ignore. And this part is basically the sum of k plus n minus 1 terms. Okay, so that is sum of array. Now obviously this is not the sum of array because we have to ignore that, right? Ignore that thing from the sum of array. So we are just ignoring. Okay, we are just ignoring. And we know one thing, that the maximum value of answer, it can be if we are putting the position at the end, that will be the maximum value. Okay, it can't be more than that. So it can't be more than that. From that we can just assume that this is, so I'm just assuming the maximum value of answer. Okay, done with it. Now for every specific value I'm going to find the mid. You know, this is the formula basically for L plus R by 2. This is the formula for that. Just to not get into the overflow thing, I'm just doing this. So now what we are going to do, first we are going to find the sum 1, that is this sum. Okay, the sum which is at the beginning. So basically, whenever we have this number line, if we are pointing at mid over here, so we need to find only this sum. This sum you can find, but it's not needed. This is not needed actually, but you can find for you better understanding. Okay, I have found it, but this was not needed actually, because if you know like this value, so you can just directly calculate it. So basically S1, we have got this by using the mid into mid this thing, and then we are going to ignore it. So every time, remember one thing, we have to ignore something, right? What is it? It is the sum of first k minus I terms. I mean k minus I integers. Okay. Actually, whenever I'm getting my hand over here, so the focus gets changed. So that's the reason I think my face will be blurry sometimes. See again, like when I put my hand over here, my face gets blurry. If I put it out, my face is, it's still, yeah, now it's okay, right? So this is some thing with the camera. I'll fix it. I'll fix it later. So basically what happens is, like, let's say this thing, okay, so we are ignoring it, and S2 is basically the total sum array minus S1. Okay, so because since we know that this is the, we know the value of this, we know the value of this, so we can obviously find the value of this by ignoring it, I mean just differentiating it, right? This is simple, I guess. So we get the S2, and S2 minus S1, that is what we need to find the absolute value of S2 minus S1, right? Or S1 minus S2, either ways it works, because since it is the absolute value, you can even go for S1 minus S2 if you want. Okay, and if S1 is lesser than SA into SA by 2LL, that is the condition that I was telling you, then we can shift L to right of mid, and if the reverse is happening, so we can shift R to left of that. But if it is equal to the exact sum by 2LL, so at that case we can say that we have found the most optimum solution, that is we have divided the whole array into two parts having equal sum. So that is, answer is already 0, so we don't need to perform any operations after that, so we can directly break through it, and then we just print the answer. Okay, you can see that it will be accepted. I'll just show you. I think not much people are active today. I don't know how many people I get it, because today's contest, it was like division 4 contest, so not a big issue. Okay, if you're not active, okay, it's understandable. Anyways, it got passed, right? This guy told me to do from D, and like I'm now doing, I think I'm not now doing E, right? So this guy is not over here, so I just ping him in case he comes. Okay. I think this slide is like too, what do you say, it's too light. I should make it a little bit warm. This feels good for me. Okay, this feels good. Okay, so let's get into this E. Okay, real quick. So Klee has an array A of length n. Hi bro, hi. How many questions did you do, Abhishek? Like this slide, if I'm taking this slide, it's difficult to code, I mean difficult to type, because it's just too harsh on my eyes. So let me just change the, I'll just dim it down a little bit, and now it's okay. Okay, so anyways, Abhishek, if you have joined now, I explained from A to E already. Okay, I explained from A to E. So I'll just explain F real quick. So F is like F is Firefly problem. Division 4 is under it now. Yeah. Abhishek, do you want to see something? I'll just show you. Okay, I'll just show you something. I was one question shy of solving all problems. Okay, so you solved like till F or till G2. Like the moment I heard that this is unrated, I just left my laptop and I just went like, okay, I'll just stream because I was not like I solved till F, I guess, when I was doing that. Okay, the moment I felt, I just left my laptop. I'll just show you one thing. This is what it looks like. So I did this G well after, like just before starting the video. So I started late because of this. Okay, so I was like taking rest and then I realized that okay, so it's so basically, see Abhishek, I made a new account. Okay, so it's like advisable never to make a new account, but I made a new account because one of my previous account got banned. I don't know why. Okay, so I made a new account because I need to have two accounts at least, so that I can give some hundred like contest. See, like whenever I'm working for serious stuff, so I give it from one account, and when I'm working like just casual, so I give it from another account. So I made this account, and today I thought that I'm going to get a positive delta. Okay, I'm going to get a positive delta, and this was my rank. Okay, so this was way lesser than that when I solved it. So I was expecting that I'm going to get a good like ranking, but anyways, it got effed up. Okay, so let's get to F. It got effed up, so let's get to F. Okay, Firefly's queries. So it's basically like you're given an array. Okay, you're given an array, and what you can do is you're going to store the array like this. Okay, you're going to store the array at cyclic shifts, the ith cyclic shift, and this is a concatenated form. My target was to upsolve till both G's, but in F I got stuck. Okay, so you did F or you didn't do F? So let me just show you like how this array looks like. So let's say if we have X, Y, Z, this is the main array. So the modified array looks like X, Y, Z. Then didn't do F. Okay. So I'm explaining F. Anyways, I'm explaining F. Just focus on this, okay? Abhishek. So Y, Z, X. Then Z, X, Y. So what happens is basically we are just shifting it by one cycle at a time. Okay. Did I do it right? Like 1 second, let me just check it. Okay. So it is like after shift it looks like ax plus 1, right? Yeah, I think that is right. Okay, so this is right. Okay, so this is what your array looks like after having it. Codeforces is slow. You know why Codeforces is slow? Because like Codeforces is a very good competitive programming platform. Okay, and most of the competitive programmers out there are on Codeforces. So it is basically like lead code. It is obviously better. Like lead code, the developers of lead code, they are doing some great job. Okay, because they're like not only focusing on competitive programming, they're also focusing on DSA. I don't know why my camera is shifting its focus. So they're also focusing on DSA, so that's the reason like they have to just let me the camera. Okay, now it should be good. Yeah. So yeah, with nothing to do with it, it's basically with minimal CSS. Exactly. No, not exactly. I won't say that exactly, but it's basically like there are too many coders out there on Codeforces. Okay, so it's not easy to handle the traffic. And if you look at Codeforces, like the compilers and submitting of the problems, it gets difficult. And even Codeforces has made some mirror efficient querying, table loading. So, see, from our point of view, we don't know how Codeforces is developed, so it's easier to say that some of the basic, like some of the most known errors that occurs. So we can just say that this is the error that has occurred. But I don't think that they make this site so easily. Okay. So, anyways, let's get into the video. Okay. So this is what the array looks like after like you concatenate it. Okay. Now what we can do is we have to like we are given two positions, and within that position we have to find the sum. So let's say we have given this to this and this position. So from within that position we have to find the sum. Now what we can do is we can group this. Okay, we can group this separately in counts in groups of 3. Okay, so once we have grouped it in groups of 3, it's basically easier for us to compile, like for us to execute this. Okay, how is it easier? So I'll just tell you what is happening to this focus thing, man. So how is it easier? So I'll just tell you. So from this point of view, if you know the value of L and the value of R, so you can find the at which group this L and R belongs. So let's group it as this is group 1, this is group 2, and this is group 3. Okay, so R belongs to group 3, right? And L belongs to group 1. So any group which is between this 3 and 1, we have to take the sum of that groups as whole. Okay, so basically the sum of this whole thing is going to be added multiplied by the groups between them. Okay, so any groups that is between R and L, that is over here it is 2, so we have to just add it simply, no need to perform anything on that. But if it is like now we know this. Okay, now for this specific this group in which L belongs, and for specific this group in which R belongs, now we have to compute how we have to find the sum for that. Now for this in order to find the sum for this specific group, so we have to find the index of L. Okay, how are we going to find the index of L? So by to find the group of L, we can just divide it, right? Divided by n. And in order to find the index of that, we have to just make it mod. Okay, mod of n. Now remember one thing, over here I am just showing you like 0, I am showing you like 1 2 3, but it should be 0 1 0 1 2, because it is always 0 based indexing, right? 0 1 2. So based on that, we know that this sum is already included, this xyz sum. Okay, so x plus y plus z, it is already included. But from this point of view, we have to just find the sum of y plus z. We don't need to find this x, right? So this x is basically excluded. So let me just exclude it. So this x is excluded. And for this r also, this x and y are excluded. So we don't need to find this. Clear? So what we need to find is basically this, and this whole thing, right? Just be responsive, okay guys, just be responsive so that I know that you guys are watching this. I thought that Abhishek is watching this, but from my side, it's showing that there is only one viewing. Okay, so I'll just ping Abhishek. So, anyways, where were we? We were like, okay, we were just doing this. Okay, just we have to just focus on the green thing. Yeah. Okay, right. Just Abhishek, just be responsive. Okay, just respond, because sometimes there is a glitch on YouTube chat, so I am not being able to like understand like how many people are watching it right now. Okay, so that's the thing. So now we know this. Now basically over here, what we have to find is this YZ, right? So this thing. But if we look at over here, we have to find XY, right? So basically this thing. So we can find this using the some operations on this prefix sum, okay, on this array. But what if it was like we had to find this whole thing, that is ZXY. Now there is no sub array in this whole array which is ZXY, right? In that case, what you have to do is you have to basically append this whole thing with it. Okay, just append it blindly, just append it. Okay, so just append it. So write XYZ after XY, after XYZ just write XYZ. Now we can say one thing, that now this ZXY is over here. So no matter whatever you are going to, okay, there was a lag. Now it is okay, I guess. Yeah, now it is okay. So basically what happens is whatever you are going to have, like, okay, so whatever the sub array is, you can find it from here. So if this is XYZ, so we can see that this is XYZ. Okay, I'll be using a different color. So let's use pink. Okay, I'll just use pink. Okay, no, pink is not getting used. Can I use some other color? Can you use a lighter shade? I'll use purple. More like this purple. I mean violet. Right? Violet is also not that good. I need a color so that it's better for you guys to understand. Let me use brown only. So it gives a grayish type of thing. Okay, let me use red only. Like for here, I think red is not used. So you can see that one thing, that for this XYZ, this XYZ is over here. For this YZX, okay, there is YZX over here, right? And for this ZYX, ZXY is also over here. Clear? So basically what we can see is that we can reconstruct the whole thing just by appending it once. After we append it once, so we have to find the prefix sum for every specific, like from every specific position we have to find the prefix sum from this position, and then from this position, okay? Because there are only 3 positions. So from that we can find the prefix sum, and based on the prefix sum we know one thing, that we can find any sum that we need. Okay, so basically based on the group that we are at right now, so we have to start the sum from that place, and the position that is like whatever the position, so that tells us whether if it is L, so we have to begin from that position, and if it is R, we have to end at that position. Okay, so if it is R, we have to go from this group thing till R. Okay, till R. And if it is L, so what we have to do is, so let me give you a basic thing. Okay, so let me give you a basic thing. So from here we can say that L is basically 1. it is basically 2, but since we are going to consider only 0 based indexing, so it is basically 1. So 0, 1, 2, 3, 4, 5, 6. So R is 6, right? R is 6. So from this, if we are taking the group, so 1 by 3 is group 0, right? And 6 by 3 is group 2, right? This is group 2. And the position is going to be 1 mod 3, that is position of 1. So it starts from position of 1, right? And this is going to be 6 mod 3, that is position of 0. So it starts from, that it ends to position of 0. So we can find for the group 2, that is this, we have to find the sum till position of 0. So basically we have to find the sum for, so I have been struggling in 1400 problems, like I have selected this level for practice for now. Most of the time I'm seeing some solution and realizing that, oh, I didn't see or realize that. It's okay, it comes with practice. Okay, you don't have to like be too much tensed about that. It comes with practice. So basically what happens is whenever you're going to take this Z, so it basically means that you have to find the sum of this. Now for this specific thing, what is the group? It is 0. So 0 means the group is going to be, let me use green. The group is going to be this. The group is going to be this, right? From that, we know that position is mod n is 1, right? So from that, we have to find the position of 1. That is this position. So we have to find the sum of this. So I hope this is clear. So now we can see one thing, that from using some basic mathematical approaches, we can come up with a solution for this. Because the basic thing, the basic logic of this problem is very clear for you, I guess. Okay. So let me just go with the mathematical approach. I'll just show you the mathematical approach. So this is Firefly queries. Okay. The code is a little bit lengthy. You don't need to worry about that. So let's say we have an array n. So array ARR of size n. So we are just taking the input, and this is the prefix sum. As I told you that we are going to make the sum, make the array, just we are going to append it. So it is going to have the size of n into 2, right? Now prefix sum of 0. So this is, I'm just calculating the prefix sum. So for the first n terms it is same, and for the next n terms we are just duplicating it. Okay, we are just duplicating it. Clear? Now for every query, what we do is we are taking L and R, and since L and R are in 1 based indexing, so we have to first make it 0 based indexing. So we are just subtracting 1 from it. Now SH1 tells us group of L, and SH2 tells us group of R. Okay, so we get the group. Now this thing is basically, this thing happens when, if there are, as I told you, as I was telling you, so if there is any group that is in between them, so we have to consider the whole sum for that. Okay, so if there is any group between them, so we have to find how many groups are between them. That is SH2 minus SH1 minus 1. That is a basic formula, and we are just doing the sum, whole thing, because prefix sum of n minus 1, that is till n terms, it is basically the sum of all n terms, or the first n terms. Okay, and since with the arrays of size n, so we can do it. This is normal. Now we are going to go for PSH1 and PSH2. That is, we are going to find what is the position of that specific element in that specific group. Okay, so it is position of L in group SH1, and similarly this is going to be the position of R in group SH2. I hope this is clear. Now what we are doing is basically we are just incrementing it. So that is, now if you notice one thing, so whatever the group is, it is telling us from which position to start, and the index is telling us from that position how many positions that we need to go towards the right. So basically if we add them, so we know from which position it is belonging to, so we can find the position of X, L and R. Okay, because if we see over here, so it is 0 and L is at position 1, so 0 plus 1, that is 1. So we know that we have to start L from Y. And for this, the position is 0 and the group is 2, right? So if we sum it up, so it is 2. So we have to start from Z. Right? I hope this is clear. I hope this makes it clear. So basically from now, what PSH is telling us, which position to start or end. Okay, start, like this is start. Okay, this is start because this is L means that you have to start from that position, and R means you have to end at that position. Okay, so there is also one thing, that is SH1 should not be equal to SH2, because if the group was same, okay, so let's say both of them belong to the same group. Okay, both L and R are of the same group. So in that case, we don't need to compute R and L separately. We can compute L and R directly using one operation only. Okay, using this sum, prefix sum only. That is also a different thing. So I'll explain that later. So first let me explain whatever I was telling you. Now if this happens, so left is basically like the prefix of left, and right is basically the prefix of sh plus n minus 1. Why is it sh1 plus n minus 1? Because this is going to tell us what is the last position. Okay, now we know that sh1 tells us which group it is starting from, and every group is going to have a size of n. So if we add n minus 1 to that group, it is going to tell us what is the last element of that group. Okay, and this is just like a normal thing, like you have to find the prefix sum of PSH1 minus 1, because you know that we are starting from PSH1, so anything before that ignore. Okay, anything before that will be ignored. So that's the reason we are just doing this. Now answer plus equal to right minus left. Similarly for the other thing, so what we do is we have to now the opposite thing happens. Okay, now we have to end it over here. Now since ending it over here, so we know that PSH is the position where we end it. So end it over here. Okay, and left is basically till how many positions we need to escape it. That is the first position of that group. What is the first position of that group? The first position of that group is SH2. So first position of group SH2. Now we have to ignore everything before that. Okay, so that is why we are doing SH2 minus 1. Clear? This is clear. Now what if both are in the same group? So if they are both in the same group, so we don't have to focus much, because it is going to be PSH from PSH1 to PSH2. That is PSH1 to PSH2. So we take all till PSH2 and ignore anything that is before PSH1. So I hope this is clear. So let me, like, I'll just compile the code, and I think obviously it will work because that was accepted. Okay, so it worked. Okay, so if you submit it, you can see that it also works. Now I'll just go with this G1 once. Like I haven't done it, like it didn't get accepted, but I can just show you some time limit thing. Okay, the problem statement has been changed. What are the changes? They just remove the hint, I guess. Nothing much. So basically this is the easy version. So over here we don't need to focus on R. Over here we are just going to focus on L. So what it's telling us is that if we have a value of L, okay, at every position we are going to for every query we have a value of L and value of R, and we are given an array, and we are also given some numbers, that is n, k and q, I guess, right? Yeah, they are n, k and q. N is the size of the array. K is basically okay. Anyways, if any one of you have any doubt regarding like anything from A to F, you can just like write it in the live chat. Okay, write it over here. Any doubt? Okay. So the following line. Okay, so basically you have this thing, and for every specific query, so for that specific subset, you have to find like how many numbers you have to change so that the whole subarray becomes okay, no doubt. So whole subarray becomes like consecutive. Okay, so what you can do is like, let's say for this, so if we are taking from 1 to 5, so from 1 to, let me just do one thing, let me just copy this and go to Excalibur. So this is the benefit of using Excalibur, because I was using Paint earlier, but I think it's not that good. Okay. So basically this is like, anyways, I think I messed it up. Okay, so basically this is the value of n, k and q. So for now I'm just separating them. Okay, so let me just take the values separately. Okay, so if we talk about this 1 comma 5, so it tells us that from this we can say that it means 1 2 3 4 5, right? So this last two elements are not there. Okay, for this the first and the last element is not there. The first, the last element is not there, and for this the first two elements are not there. So this is what the subarray looks like. So if you look at it over very carefully, okay, let me just make. So if we replace, okay, so if we replace this 3, I mean this 2 with 4, and this 1 with 5, then it works, right? I don't know, like should I make it a little bit bigger? I'm not sure actually, like whether you guys can see it or not. Let's make it a little bit bigger for you guys to understand, better understanding. Okay, since now we are focusing on this 1 comma 5 thing, so let's make this bigger. So basically what we can see is that let me erase it. Okay, so what we can make is this, we can make this as 4 and we can make this as 5, so that all the elements are now consecutive. So the minimum number of operations that we need to perform is 2. Okay, so how we are going to find it? We can just take up the maximum number of consecutive elements in the whole thing. Okay, so how many maximum number of consecutive are there? So this is 3. So from that 3, if we subtract the whole, I mean from the whole length of the subarray, if we subtract this 3, so we get the answer, that is 2. Over here, if you look, okay, first let me just increase the size. So this is for 2 comma 6. Okay, so 2 comma 6, if you look at this, so this 2 and 3, just let me use a laser. Okay, you can see one thing, that for this 2 and 3, they are consecutive, and again this 1 and this 2, they are also consecutive. So basically we can either take them or take them, and in both cases we know that it is going to be, the maximum consecutive is going to be 2, and from 5, if we subtract 2, the answer is going to be 3, right? So earlier the answer was 2, now the answer is 3. For this, let us check. Okay, let us check it quickly for 3 comma 7. I don't know, I think anyhow the 7 popped up. So from the 3 comma this thing, so what we can say is, so I'll just use the laser again. So see, 1 to 3 is consecutive, okay, and this is the maximum. This is the maximum that is occurring. Nothing else is consecutive. So basically the consecutive is 3 and 5 minus 3 is 2. So the output looks like 2, 3 and 2, right? So output basically looks like 2, 3 and 2. If you look at the problem, it is 2, 3 and 2. Okay, so that's it. Now if we want to have an approach about this problem, what we can do is we can use some sliding arrays, sliding window. Okay, like a basic approach will be to do some brute force and check for every specific subarray and do it, but it will be better if you use a sliding window. So what we do in the sliding window is, like, I'll just need to copy this. Okay, I'll just copy this and then delete the whole thing and just paste this. So we're going to perform the sliding window on this. So actually it was not 1 2 3 2 1, it was 1 2 3 2 1 2 3. Okay, so we know this. Okay, so for the sliding window, for the sake of sliding window, what we can do is, for the first 5 numbers we can find, okay, we can just do the brute force thing for the first 5 numbers. That's good. Now we can take a multi-set. Okay, in a multi-set we can find out this 3 can be grouped, this has to be grouped separately, and this has to be grouped separately. So what is the multi-set going to contain? It is going to contain 3, 1 and 1. Okay, for now. Now the moment we are going to here, this thing, okay, so just let me change the color. The moment we go to here, now one thing is added over here and one thing is eliminated over here. Now this elimination will affect the first element by reducing it by 1. Okay, so basically if we go to that position, so this gets reduced by 1, so it becomes 2 comma 1 comma 1, and over here, so basically we may think that we have to append a 1, right? So we may think that we have to append a 1 over here, but that is a very bad approach. I appended a 2, okay, or 1 over here. So that is a very bad approach, because these two, they can be grouped up. So based on the last position that has occurred in the previous sliding window, we have to find whether this is going to contribute to this or not. If it is going to contribute, then just make this 2, just add 1 to it. And if it's not going to contribute, just add a 1. Not big issue, okay? Not a big issue. So till now I guess this is clear. Now we are going to the next sliding window. This is the sliding window. Now 3, again this thing gets cancelled out, and we have to find like whether this thing is contributing to it or not. Yeah, this is contributing, so this is becoming 3. So every step we found that for the first step, like now I'm going to just go for the green. Okay, green was the first step. In the green, the maximum was 3, and 5 minus 3 is 2. In the blue, the maximum was 2, so 5 minus 2 is 3. And in red, the maximum is again 3, and 5 minus 3 is 2. So that is how we do it. Okay, 2, 3 and 2. Now how we can find the maximum by using the value of max thing. Okay, so that takes us big O log n. But there is something bad about the multi-set, is that it's not that compatible. So I got a TLE, I guess. Okay, I got a TLE. If you look at this, my submission, you can see that I got a TLE for that. So what you guys can do is, you guys can just think about a better approach, but I'll just go on with the code because I couldn't find a better approach for now. So what I did is I found a DP that is going to store the values for every specific place, and I'm taking the input of ARI and taking a separately vector BRR, so that is going to store this thing. Okay, this thing is stored in BRR. And what I do is, if it is consecutive, just increase the count, that is f, and if it is not, then just push f2 over here, f over here, and make dp of 0 as maximum of that. Okay, and f equal to 1, and at the end also you have to push it to over here. So this is basically what as I was discussing. And this dp thing, okay, it's just the reputation of this thing. Okay, so this is just a reputation of this thing. And dp of 0 is k minus dp of 0, as I told you, because whatever is the maximum, you have to subtract that from the total size of the subarray. Now you're going to take a multi-set, and you can insert all the values of br of I into the multi-set. And what you can do is, you can use a sliding window, and for every specific element, what you do is basically you take some elements and you decrease the size of the segment at the start of the table. Okay, so what you do is basically you find the br of l. Okay, so br takes the values, right? So l is initially l equal to 0. So why I do this, I'll also tell you. Because let's say at one position you find that this becomes 0, so in that case you don't need to consider this, right? You don't need to consider this, so you have to move on to this position. So that's the reason I have taken this l thing. So that thing, like whenever I'm getting a 0, I can just move to the next position because I don't need to consider it. And this happens that we erase. Now I use this dot erase dot find, so that we erase only one occurrence. Okay, erase only one occurrence. Otherwise it will be like ambiguous if you erase more than one occurrence, right? So br of l minus minus. So this is basically the thing, sliding window thing. And if we find that it is the end of the thing that is added after sliding the window, if that is making it consecutive, so you have to make this plus plus. Okay, you have to make it plus plus. Otherwise you have to just push a 1 to it, as I was telling you. That if there is something else, you can just, if there is if it is not consecutive, you can just push a 1 to it, and if it is not, if it is consecutive, then you can add a 1 to it. Okay, and at the end you have to find what is the largest segment size in it, and you can make k minus dp of I. Okay, so this is it. But it will be giving you some TLE, so you can check the conditions. Okay, like it gave TLE, I think, at a very last position. Okay. So whenever the input was very huge, so it gave me a TLE. Okay, so basically it was like TLE error. The logic was perfect. So what you can do is you can optimize it. I haven't optimized it yet, so I'll just try optimizing it tomorrow. So if I optimize it, I'll just post another video maybe on this, or I will just post the solution on Discord. Okay, anyways, if you haven't joined the Discord, the link is over here. Okay, you can join it from here. And this is my Instagram, so give it a follow. If you have any doubt, like, it will be better if you want to ping me like on a personal basis. So Instagram is preferably. Okay, so that's the reason I have kept this Instagram thing. So that's it from my side. Okay, let me do one thing. Like, I'll just put an end to this video, because I think I've been explaining it for too long. So let me just end this video. Okay, so that's it. So should I end this video? If anyone is watching this, should I end this video? I hope this is clear. Everything is very clear. So should I end this video?